Hi guys, welcome back to the channel. In this video we are going to discuss universal shift register. So let's get started. In the previous videos we have seen these four types of shift registers. So that is serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So these four types of categories we have seen. So what if all these things can be possible with only one circuit or one diagram? So that is known as universal shift register. So let's see how to build that. So basically this is the preview of universal shift register. Only I have shown the some applications only it can perform the left shift also. Let's see the circuit diagram. In the universal shift register we need to understand the truth table first. So in that we are going to use the 4x1 multiplexer. In the 4x1 multiplexer we have already know about it has two select lines, that is S1 and S0. If both are 0 0 we are going to perform hold, means the previous state is equals to next state. If 0 1 right shift, 1 0 means left shift, and 1 1 means parallel loading. Basically these are all the things that we are going to have in the universal shift register. So shift left, shift right, parallel input, hold data, these are the conditions, right? So that is the thing that we are going to have the 4x1 multiplexer. Now I will say you shortcut trick to remember how to draw the universal shift register. First of all we need to have the 4 flip-flops, the 4 all D flip-flops, and all are synchronized with the clock like this. The next step is to take the 4x1 multiplexer with the select lines S1, S0 for each of them. So we can connect all of them at once because all are same. Now let us start joining all of them. So if you connect the blue lines, that is S1, and red lines, that is S0, you can see over there. For all the multiplexers, one job is done, that is the select lines is completed. Next the output. So if you see the output is directly connected to each flip-flop's inputs. So first flip-flop D3 input should be directly connected with 4x1 multiplexer output. Like that you have to connect all the floor outputs, means 4 multiplexer outputs to 4 flip-flop inputs. So the remaining thing or left thing is uncovered in this 4x1 multiplexer is I0, I1, I2, I3, that is inputs. Now we are going to connect the inputs also, that becomes our whole universal shift register. For joining the input lines for the 4x1 multiplexer, we need to understand the truth table first. In the truth table, S0 and S1 as 0 0, we are going to perform the hold condition. So basically we already know when S0 and S1 are 0 0 means we are going to select the I0. So in that situation we are going to connect the I0 with the outputs itself. So Q3 will be connected to I0. The second flip-flop I0 will be connected to Q2. So Q1 will be connected to the next flip-flop, means next 4x1 multiplexer I0. Like that you have to connect with the blue lines. Because the previous output is again retained or stored or hold condition in that situation when both are 0 0. The next one is if S0 is 0 and S1 as 1, we are going to perform the right shift. So that you can observe there, I am starting with the second flip-flop D2. So simply write just the Q3 in the I1 of the second 4x1 multiplexer. So Q2 in the I1 in the second 4x1 multiplexer. So you might get it out why we are writing in the I1, because when S1 is 1, S0 is 0, we are going to select the I1 as input. So in the fourth one also you are going to write Q1. So just shifting to the right word, and the last means completing the last one as the right shift Q1. Again you are going to come back to the first 4x1 multiplexer, and in the I1 you are going to write the Q0, the last flip-flop's output. Then if you want to perform the left shift, you are going to have the select lines as S0 as 1 and S1 as 0. For that you can also observe when that 1 0 is for S0 and S1, we are going to select the I2 in every 4x1 multiplexer. So for the left shift I am starting with the last but one multiplexer, 4x1 multiplexer. There I started with the previous output, that is Q0, come back Q1, come back Q2 means the first one. So again go to the last one, that is Q3, you can write the previous means the output Q3. So likewise you can perform the left shift. And finally if you want to load the parallel data from external data, when you are going to pass both S1 S0 as 1 1, that means you are going to select the line I3. So that I3 can in the all 4x1 multiplexer you are going to pass the each and every required or selected flip-flops inputs, or the parallel load you can pass like B3, B2, B1, B0, you can pass according to your wish. So this will load the parallel load into the flip-flops. So this is the full overview of the universal shift register, that what you are going to perform, that according to your requirement you are going to select the select lines and you are going to use this universal shift register. So now let's see some applications of universal shift register. So the first one is data conversion, data storage and manipulation like arithmetic operations, data manipulation, sequence detection and generation, other applications like given there. So in the upcoming video, we will discuss each one very detailedly like PRBS generation, sequence detection, so arithmetic operations, these and all things will be detailedly discussed in the upcoming video. So stay tuned. I hope you understood this video. Thanks for watching up to now.